How to create the perfect set of test data. Tools, approaches, and strategies to provide developers, testers, and the CI/CD pipeline with the test data that they need. Here's a short agenda. Firstly, a quick discussion on the problem and the strategy and approach to solve the problems. Then we'll move into a series of demos, firstly building and using a test data mart, then finding data and allocating data to specific test cases. Then we'll talk about how you link those finds to makes. And finally, we'll talk about how you provision your test data into your environments at the beginning of sprints. So how do people currently find and make their data? Up to 50% of a tester's time can be spent finding or making data. Finding data is random. Finding data is not structured. If you can't find data, you have to make it, or quite often you may well just ignore that particular scenario or test case. People don't reuse what others have done already. Data is not integrated with any of the DevTest CI/CD toolchain. So if you think how testers and developers currently have to find and make data, it's very unstructured. They have to go into many systems, they might have to put data directly into a database, they might have to create messages, flat files, they might have to put it through the front end. In addition to that, there are other testers and developers also fighting for that same data. It's rare that you actually have your own development environment unless you're using something like virtualized databases. The result of this, it's slow, it's random, and it's unpredictable. So let's use a much more structured approach to being able to find and then make data. So the first thing to do is to split the business from the technical. So by the business, I mean the standard business terminology that users are familiar with the technical, which is the detailed implementation of how the data is stored inside databases and files. You create shopping carts, which are aggregated views of the data. As extra business attributes appear, you just add them in. The point here is that you don't need to solve everything at the beginning. You can just start with maybe the most common 80% of business attributes that you care about, and then as you move through your automation and your testing, you just add in extra business attributes then linked to the technical world. Once you've got this working, you can then think about maybe using allocation, which allows you to separate data from other testers and developers. You can also store user searches over time, which means when you come to refresh your databases or environments, you can recreate the data based on those searches, and I'll show you this in a demo later on. You can also think about modeling, which is the idea of coverage or combinations of data. So when you provision the environment is already provisioned with the majority of potential variations of data. And you can also think about integrating your finds into your automation. So when you define an automation script, you basically define as part of the automation script what type of data it needs, not maybe a specific account number or user ID. Now let's look at a much more structured and predictable method of finding or making data. So what we're going to do is we're going to create a test data mart. Now a test data mart is basically an aggregated either table or view or group of table or views that look at the underlying technology, whether that be on the mainframe, whether that's inside traditional databases or on message queues, or you might even run some reports and parse data out of those reports. Now at its lowest level, it's a very technical set of data. It contains information that's come from fields in flat files or VSAM, but the view that the user would see would be in language and terminology that they would be familiar with. For example, the number of bankruptcies, currently in default, late payments, age, etc. Now the tester or developer is looking for data in the data mart. They're simply casting queries, and we'll show you that in a moment, either using SQL equivalent or using forms, and that is how they're going to go and find the data. Now, as any new attributes are required, all you simply do is add them to the next either build of the table or data mart, or just add them in as extra attributes into the views. You can also add in allocation, and allocation allows you to make sure that testers and developers don't step on each other, don't cannibalize each other's tests. You can see here that tests 1, 3, and 4 are actually using account number 2, We're only interested in that for the point of view of reading the data. We are not going to be transacting against key ID number 2. Now, if you can't find any data, this is where it gets interesting. What we're going to do is we're going to analyze the query. The first thing we're going to do is to look for similar data. And you could potentially just modify the data in your existing test databases to make sure that the query is then satisfied. You could clone existing or data that is very similar to it, or you could potentially make new data. Now, the data that is created or modified can either be put directly into a database using our synthetic data generation engine. We may well create some messages which could be put onto message queues. We might put data into flat files. We may use an API, which is a very common way of being able to create data. Or we could put it through the front end and we could have just recorded some simple Selenium scripts to push the data in the front end. Once this is complete, the data is then returned to the developer and tester. From the point of view of the developer and the tester, all they're doing is issuing the find, and we take care of the rest. So let's move into the first demo. I'm going to show you a little bit how you can build a data mart using tables and views, how you can go about finding data, either by using raw queries or using forms, which are much more business focused. And then I'll show you around how the allocation works. So in this section, I'm going to show you 3 different examples. So we're going to work with the Wide World Importers SQL Server database. And what we've got here is an aggregated table called Order Details Aggregate. And what we've done is used a bit of T-SQL to mine the data for all of the orders across quite a complicated database. And you can issue SQL against this. Now what we've got is a little form called find data using SQL. Now in this case I'm going to put in raw SQL. Later on we'll actually look at submitting them through forms, and I need 20 of them. I'm just going to put the results over here and let's fire off that data search. Now let's look at the results. So this is a little summary report. I mentioned the ability to look for similar data. Now we have the initial query. And what we're doing here is if we cannot find enough data, so we're found 18 out of 20, we're looking for reduced queries. So we're trying to find similar data. So we will parse the SQL and in effect reduce it down until we satisfy the query. We'll also produce you a little report. So it says found data not enough. So we were looking for 20, we found 18. And then each one of these is a different query, which could potentially satisfy it. And later on, we'll use this similar data and modify it to satisfy the query. So now we understand how to find and look for similar data. What we've done is set up a job which will apply updates to similar data to match if the data is not found. So let's just fire that job off. Now what we'll do is we actually analyze the SQL and work out the values using some clever algorithms to work out what values would need to be set in the data itself to satisfy quite a complicated query. Now if we go and look at the results, you'll see that what we've done is we've actually created a set of update statements, and we've chosen the similar data with the order line IDs, and we've assigned the values to that data. Now if we actually run query again, you'll see now we actually have enough data. So we've gone from having some data that was relatively close, we've now updated it, and that data will now satisfy the original query. So our next example is a little Oracle transaction database. Now within here we have a bunch of customers, orders, items, products. Now there's not that many tables, but there is enough complexity in here to just show off the features. Now what we've done here is we've created a little summary view, and I'm just going to show you the way to build that up. So in our world we care about customers, and if we look at the data in the customers, and what we've done is for each customer we're interested in the orders that are being shipped to them, and there's all sorts of different statuses of orders and there's different dates, etc., that we care about. Now if we look at the data for each customer, you'll see the current state of play with each customer. As orders come in, because this is a view, this will be updated. Now what we're going to do is we're going to search for some specific orders. Again, I've got a general search query, but in this case what we're going to do is we're going to look for 10 of them. Now what I'm interested in is I need to know how many current late orders there are out there. So I'm just going to say minimum placed orders. Now in this case I'm interested in running this query again later on, and I'm just going to say current late orders. Now let's fire this off and see if we have any data. So that's completed and found us some data. Now, if you remember, when we fired off the original query, the form itself contained business terminology, minimum credit limit, etc. Now, what we have sitting behind is a configuration file, and we can pick up any standard term and we will link that to specific columns. We've got operators, and actually in this case we're referring obviously to the view that we care about. So that's how we can convert the technical, which is the data sitting inside the view, to the actual forms themselves. And the other thing that we did was we stored the query. Now, what we have here is we have a set of queries. These are the standard queries that we need the database to contain. But you can see current late orders, which is what we actually requested, has now been stored. Now, later on in the second part of the demo, what I'll do is actually show you how we can use this set of stored queries to actually populate the database so that all of these queries will be satisfied when the environment is provisioned. So I'm just going to take a few seconds to show you an example using allocation. This is the actual logic that we use to apply the allocation. But in a nutshell, if you want to have a set of data that you're just going to read, then of course others can read it. If you're going to transact against the data where you are likely to change the state of the data, then you need to have a unique lock against it. So in this case, we're going to use another SQL Server cube that we've created. In this case, it's a combination of a set of synthetic customers with their associated social security number, and we've mined data from our development systems, which in this case is a little Siebel system. What we're going to do now is just like we did before. We're going to build up a query. I'm looking for a female, status code 1, and I'm looking for an other policyholder. Now in this case we're going to say use allocation, and we're going to give it a name, female other policyholder, and we're going to click execute. That's completed. Now what we've done is we've created a list, and if we come in and have a look at insurance master allocation, now this is slightly different in that we've linked the search criteria to our allocation engine. You'll see that we've built up the search criteria as we did before. We've gone in female other policyholder, and we found a set of social security numbers. In this case we've set up as a read. If we want to come back and change that to a write, we could. Now sitting behind, using our allocation engine, we'll go to our insurance pool, which is where we're tracking anything to do with the insurance testing. And you'll see here, these are all the different social security numbers. And here you can see manual test female main policyholders, and this is where we're actually tracking an index of all the test cases that are assigned to the different test cases that we have created. So now we're going to have a look at how we would take the finds, and if we can't find any data, we need to think about either modifying data, cloning data, or making data. So let's go back to our Oracle transaction system. We've run a bunch of finds and we have some missing data. So we can either update some existing data, which we showed you before. Now we're going to show you how to clone data or create new data. So to clone data, click on the Clone OT Customers. Now here we can pick out any rows we want and decide how many times we want them. In this case, we don't have enough of customer ID 44. We need that type of data, and we're going to create 5 of them. That's finished. Now let's have a look at the report. Now the way cloning works is that you start at a primary table and then you work your way down through the child tables and the grandchild tables. Now, if you're familiar with the subsetting, then you can also make it quite sophisticated in terms of looping across the database. And this gives you a nice little report, which is basically saying we picked up customer ID 44 and we've now created a series of order items linked to that original customer ID 44, but they have new customer IDs. Now we can run our comparison engine, and our comparison engine snapshots the data before and afterwards. It's high performance. And if we look at that, we can look to see the results of any orders added and any items added. So that's the result of running the clone, which is quite useful. Now we could also think about synthetically generating data, and that's using our synthetic data generation engine. Now it's very sophisticated. I won't go into it in any great detail, but basically you have a set of parameters, and those parameters then get passed down. Here's some status and customer IDs, etc., like so. Now that ends up in a form, and I can issue create, order, and status, and then I can fill in, I want some shipping, how many do I want, how many items do I want, between 5 and 10. I'm happy with today's order date, maybe I want to update the credit limit, and I'm going to fire that off. That's finished. Again, let's look at the results. You can see we've created an individual order, shipped, and then these are the associated items that have then been added to it. In this case, there were 10 of them. It was set up to go between 5 and 10 randomly. So that's how we can create new data or clone new data. So how do we link our finds to our makes? If you remember, when we submitted a find earlier on, we actually constructed a query from a form, and that has been captured. Now we also have a set of standard queries, and these have been defined by the user as types of data that we need at the beginning of a sprint. Now if we go back and look at the counts for those standard queries, you can see that we're actually pretty low on these. If we go back into the definition of the finds, this is where we're now linking it to either a clone, an update, or in this particular case, we're going to use the synthetic data generation job that we created before. So previously you saw that we had on our submission status of shipped, minimum orders, maximum orders, cancelled count, credit limits, etc. And all you have to do is basically carry over the values that have been calculated to satisfy the query, which we showed you earlier on, into the associated publish. So if we find data, great, we don't need to worry about it. How many do we need? 10. If we can't find 10, we will then call the associated publish and map over the appropriate parameters to be able to create that data. So here is our standard set of queries plus our current late orders one that we want to actually go and find and make data for. So let's run our conditioning. You can also vary the parameters if you want to. In this case, I'm setting the maximum date, which is one of the parameters passed down to today's date, and I'm going to fire off the conditioning. Let's look at the results. So you can see it's run its queries. It's looking for the data to see if it's there. If the data isn't there, it will create data generation CSVs, which are telling the generation tool what to do. So for this particular one, we need a credit limit of 250, order count 258, and how many rows do you create? 10. And if you look at the logs of the generate, you can see these are the values that are being passed down. It's adding it to specific customers. You've got various repeaters, the status is pending, and the credit limits. And then that is going in and running the batch process to create the data. If we go over and run our counts again, here you can see that we've actually upped all the values. There's still a few that we need to run later on. And if we go back to our base set, we keep track of the original pre-process count. So this was the amount of rows that we had originally. And after we've done our synthetic data generation, you can see the values are now satisfied. So hopefully you can see we've gone from a very straightforward form, which has then been translated into a query, and that query has then mapped over to synthetic data generation. So if we don't have enough data, we can easily create the data that we need for accurate testing. So now let's take a look at environment provisioning, or in effect creating the data you need at points in the sprint. Could be the beginning, the middle, or the end. And in effect what we've done already, we convert that into a conditioning engine, which allows us to take the user requests that have gone in earlier. We're also going to do some modeling of different types of queries that could potentially exist, and we're going to explode those. And then we're going to use the same process to run against the database to find the data. And if it can't find the data in the volumes that you need, it's then going to go off and synthetically create the data. So let's talk about environments or provisioning data into containers. Now what I'm going to do is just talk about this sort of traditional approach, which is typically you take some kind of production data, you mask it. If you are using virtual databases, which is a great piece of technology, then people can have their own copies of the database, which is great. You still have to wait for the data to be masked, and for a large database that can be a bit of a problem. Now there are some interesting concepts that we can also apply. You can also pull out specific data. So instead of having to take an entire copy of a database, you can just pull out maybe a specific bug that's occurred, or maybe an interesting piece of account history that you need to test against in your development environment. And what you can do is you can extract a subset mask it, and then clone it into your development environment. And that's kind of a much more agile way of being able to create the data. What we're going to talk about primarily in the rest of the demo is the conditioning engine. If you think about it, we have our users and our automation scripts need data, and they have sets of finds or lookups that they need. If they can't find the data, we can make it, and that is the conditioning engine that we've been showing you in the demo. You also may have some ad hoc finds that you need to run, and you can do that through the portal. But we're also going to show you how you can actually model out the potential variations of queries. And at that stage, once you have those variations, you could actually condition the database at the beginning of the sprint, or maybe you could put it inside your Jenkins build to actually populate the database or container with the data that you need right at the beginning of the sprint. So if we look at the queries that people have been entering, you can see we've got low credit, high sales support, high orders, low orders, different types of orders. Now what we can do is do a bit of analysis on this. And we've decided that there are various different things that the user cares about, which is credit, order volume, sales support, cancellations, and late orders. And we break down the queries to just the fields that we care about, or the columns. What we do then is we map that to the specific data generation that we care about, and then we map it to the parameters. In effect, these are kind of code snippets which then build up into the more complicated queries that we looked at earlier on, and the type of data that we need to create into our development system as a starter set. Now there's a couple of different ways that you can go about this. The first one is to just explode them all. We have a little utility called conditioning explode combinations, and if we come in here and look for condition master query snippets, we can use all pairs or orthogonal arrays, and you can enforce in any number of combinations that you want. I'm just going to use 3. And then I'm going to click on execute. Now that's finished. That creates an exploded set of queries based on the initial snippets. And you can see here we've got low credit, low sales support, and low cancellation and low late orders. And that then has built out the query that we need. It's also gone in and mapped in the parameters that would be required to create the data associated with that query. Now what it will also do, which is quite useful, is it kind of prunes out the ones which don't make sense. So you can't have something that's pending and also cancelled. So it's kind of a really easy way of being able to start with a bunch of snippets, link them to tests, and then explode them. So let's look at a more sophisticated and more accurate method of being able to create the combinations of data that you need in your development environments. So what we can do is create a model from the master snippet list that we defined earlier. And we just pick the job to create the model inside Test Modeler, and we click on execute. That will then create you a basic model. You can see that we've got the different types of data, and then we've got high and low cancellation, which are the kind of subtypes. Now that'll give you the basics, but what you probably want to do is spend a little bit of time building out the various different combinations of data that you actually need. So here we've got credit, low, high, medium. That's fairly independent. And then you've got low orders of volumes. Obviously you can't have low orders of volumes and high cancellations. So what I've done here is separated those out. And then inside, for example, the high orders, you could also have low cancellations and high cancellations. Now, if you look at the variations that exist, that then allows you to think about modeling out much more interesting variations of data. And the point here is what you're trying to do is to predict what the developer and tester is going to want before they come to you as a test data engineer. So this is the list of exploded combinations of queries, and what we're going to do now is we're going to submit that. So we're going to condition the database to have all of these combinations of data. So once again, do condition database and fire this job off. So that's finished. Let's look at the results. And you can see, once again, we've gone through all the different variations, and then at the end, we've generated the data that we need. If we then go back finally and run the query, you can see that we now have all of the data that we've modeled and designed in that database. And at the beginning, we had very sparse data. And in a couple of hours, we've managed to create a high quality, fit for purpose test database. So here's a quick summary of what we've talked about today. So what have we shown you? We can build and capture business queries, which means you can learn the data you need to test with. You can store and analyze the data you're looking for, which means you can build up a systematic set of data. You can break down queries to look for similar data.
So you can save time by trying to find data that's pretty close. You can calculate the data needed to satisfy the find. So you might have quite a complicated piece of SQL and will work out what values need to be created in the systems to satisfy that query. We can map the finds, the lookups, to any makes, updates, or clones that you've created. So in other words, we're using that systematically to work out what you need to make. We can model the variations of the data. So in other words, we're using the requirements to model out your data and your testing. And you can create data across multiple systems in any format. So in other words, it saves a lot of time setting up complex integration tests. And finally, it can allocate the tests based on the criteria, allowing your teams to work independently and efficiently. So thanks for watching. If you'd like to talk to me or have any questions, feel free to email me at hugh.price@curiosity.software. Thank you.